Yeah, guys. This is physics. We want to work out this problem, this scenario. I don't have the right app because, as you know, physics is summarized. So we simply have an inclined plane that's 20 degrees, and we are pushing a 9 kg body up that plane. Its initial speed is 2 meters per second, final speed is 8 meters per second, and it goes to a point 10 meters high. So that's a case. So now, when you work this thing out, the question is find the work by applied force, and most importantly, to find how much force is needed for you to get all that at point 2. So at point 1 you have initial velocity 2 meters per second, then at point 2 8 meters per second, and it is that point. So then to enjoy this question more, we'll add some friction. So say mu k is 0.3. So there's friction there. So how much force must someone apply, or what on a machine apply to push this object? So to find the force, the work by applied force, you find the work by all the forces as a result. So now in this case, the most important is, that I emphasize the most, is the speed, because that's work energy theorem. That's very good at work energy theorem. So you will say the net work is going to be equal to the change in kinetic energy. So the net work will simply be m over 2 v squared minus v naught squared. So this will be 9 over 2 8 squared minus 2 squared. So 8 squared 64 minus 2 squared, which is 4, that's 60. 60 times 4.5, it will give us the net work is 270 joules. Working from home is tough. I'll continue. That's my beloved daughter. Then the work by gravity is gaining potential energy. Work by gravity is gaining potential energy, which is gain PE, which is mgh. So it will simply be 9 times 9.8 times 10. So what is 9 times 9.8 times 10? 882. 882 joules. Then the other one is friction. So work to overcome friction is simply mu k mg h over tan theta, or if you want you can say mu k mg x, if that's what we are given, cos theta. So what you get is 0.3 times 9 times 9.8 times the height, which is 10 over tan 20 over tan 20. So you will say 0.3 times 9 times 9.8 times 10 divided by times 20. So this will give us 726, which will just say 0.9, which will just say 729 or 27 joules. So these works, these are the individual respective works that are done. So to get the work by the applied force, you will simply add them. Work by applied force with the work net plus work WF plus work to overcome gravity. So you find in the actual case you are subtracting these works because they are opposing works, but then they are also negative. So in the end you add them. So you just add the 3 plus the work by the normal, which is 0 if you want to be so smart. So you will say 270 plus 882 plus 727. You will go through these concepts on your own. Get the technique. Don't get lost in the side there you didn't round off. Then you add them. So what's 270 plus 882 plus 727? You get 1879 joules. So the work by applied force is 1879 joules. Then the force applied, because work, if you remember, is force times distance. The S here is equal to, so it's same as saying work equals F times H over sine theta. Why over sine theta? Because if you divide this over sine theta, remember your SOHCAHTOA, this is opposite over hypotenuse. So that's how you work it out. If you want, you can find what the value there is. So you say work is FH over sine theta. So this will give us 1879 equals F times 10 over sine 20. Then you can change. This one will multiply here, and that one will go and divide there. I'm sure you know how to cross multiply. You can go and do it. That's physics, Mama.
That's supporting. Thanks,
That's 64.3 newtons. So the force is 64.3 newtons. So that's all with this question. Go and go through as you are practicing. Working from home is tough, but we can't deny the reality that there's a beautiful child in this house. Thank you very much and have fun.